Hello everyone. Let's now discuss how can we solve this problem. Number of ways to paint n by 3 grid. So you are given a grid of size n by 3 and you want to paint each cell of the grid with exactly one of the three colors, red, yellow or green. Let's assume this as A, B and C. I'll tell you how we can solve this. While making sure that no two adjacent cells have the same color, that means two cells that share vertical or horizontal sides have the same color, should not have the same color. Given n, the number of rows of the grid, written the number of ways you can paint this grid. As the number may grow large, the answer must be computed 1 in 9 plus 7. Let's see the constants. So the constants is n can be going till 5000. Let me tell you how easily we can solve this without even computing what all the combinations. Let me tell you one thing. There will be only two types of combinations. Let me take those are A, B and C, the colors which I have taken. Let me take A. I can't take A again here, so let me take it here. Now what else can I have here? I can have B. Now again I can have C, right? Now in these two places, the first and the third place, I can have B and then B. Now here in the middle, I can have A, right? B, C, B. Now I can also have C and then C, C and then C, here A and then B. So it is nothing but, let me name it as type 2, right? Which is nothing but all these are having two colors in this. The you see only two colors, right? A and B, or B and C, or A and C. Now let me discuss about type 3. What are the type 3? Type 3 ABC, one thing, BCA, one thing, and CAB, one thing. If I just start with A again, A, and let me just replace these two, CB. Now if I start with B and if I replace, just swap AC, now C and then AB are swapped BA. Now this is the answer for just n is equal to 1, which is nothing but 6 plus 6, which is nothing but 12. Now what if they asked n is equal to 2? How can I solve that? Let me tell you. Let me just take this ABA. Let me just take this ABA. How many can I place below this? That's what the question. I think you got the question. How many different ways I can place below this? Can I place ACA? Absolutely no. Why? Because A and A, they are, uh, you know, uh, they are adjacent, right? BAB, yes, I can place. BCB, yes, I can place. CAC, yes, I can place. CBC, I cannot place. So there are three choices for this. Let's check whether ACA also have three choices. Let us see. Now, I didn't check in this type 3, right, for ABA. Let us stop once and check. For ABA, I have 3 type 2, right? Let us see how many type 3 I can get for ABA. For ABA, how many type 3 I can get? ABA. Can I take ABC below ABA? No. BCA, BCA, no. CAB, CAB. Yes, I can take this CAB. ACB, A and A, they are adjacent. No. BAC, B, A and then C. Yes, I can take. CBA, CBA, they are matching. BA are adjacent. CAB and BAC. So there are two type 3. Now this is about, let me write it here. For a type 2 color combination, I have 3 type 2 and 2 type 3. Nothing but 3. What is the type 2? 3 into how many type 2 I have? Let me tell you. Type 2 I have dp. Let me take type 2 as dp2 of, what is the previous one? Just I am having the second row, right? How many I can have on the first row is nothing but 1 plus 2 into dp of type 3. I'm just naming it as dp3. How many I can get is 1. Nothing but here I have 6. Here also I have 6. See here, see clearly. dp2 of 1, dp3 of 1. I am just taking 2 into 6 and 3 into 6. I'll tell you how it will be computed. Now, this is for type 2. So, dp2 of 2, I can get 3 into dp2 of 1 plus 2 into dp3 of 1. I'll tell you how it will be computed. Now, what about the type 3 one? Let me come again. Let me come again. Let us check. Here I have this ACA, right? ACA. Can I take this ABA for consideration? Yes, ABA. So ACA is having A, no, not ABA. I cannot take ABA, right? So for ACA, can I take BAB? Yes, I can take BAB. So I can take BAB, or can I take BCB? No, I cannot take. CAC, yes, I can take. So I can take CAC or BAB or CBC. I have 3 for just 1. For 1, I have 3. So how many are there like this? So for this I have 3, for this I have 3, for this I have 3, 3, and then here also 3, and then here also 3. So 3 into 6. That's what I did here. 3 into 6 dp2 of 1 type 1, here 6 into 3. That's what I did, right? Now, what are the type 2? Why I am taking only 2, right? Let me tell you. For ABA, I can take CAB and BAC. That's the same thing for everyone. Let me check for ACA. For ACA, from this type 3, how many I can take? Now, ACA, can I take this? No. BCA, I cannot take. CAB, yes, I can take. ACB, no, I cannot take. BAC, yes, I can take. I think these two are for ACA. Yes, these two are for ACA, and there will be every time these you see CAB and BAC for ACA, but for this ABA, you see BAB and all, we will be having 2. Every time we will be having 2. So 3 type 2 ones, there are type 2 ones for 3 times, and type 3 only 2. I can get only 2. 2 combinations, 2 combinations, 2 combinations. And here also 2, here also 2. That's what I did. 2 into 6. Now, what about DP? Wait a second. DP3 of 2, nothing but how many I can get, combinations I can get if I start the first layer as ABC, BCA and all. Let me just clear this for 1 to 2 seconds. It might take. Yes, it is clear now. Now let us discuss about type 3. With type 3 on the top, how many I can get actually? ABC. For ABC, let me start from type 2 itself. From type 2 for ABC, can I take this? No, I cannot. A and A. I cannot take A and A. BAB. Yes, I can take BAB. Yes, I can take BAB. Yes, I can take a BAB for ABC. For ABC, can I take BCB? Yes, I can take BCB. Are there any other CAC? No, I cannot take. CBC, I cannot take. So for type 3 with type 2, I have 2 into with type 2, right? DP2 of 1. Only 2. I am just taking only 2. Now let us consider about type 3 itself in type 3. ABC. Can I take BCA? Yes, of course I can take BCA. Can I take CAB? Yes, I can take CAB. Now for ABC, can I take ACB? No, I cannot take. Is ABC and BAC. C and C. I cannot take. ABC and C, B, A. B and B are matching. No, I cannot take. So here also I have 2. So 2 into DP3 of 1. That's how you solve this problem. Every time DP2 of I is equal to 3 into DP3 dp2 of I minus 1 plus 2 into dp3 of I minus 1 is for dp2. Now what about dp3? dp3 of I is equal to 2 into dp2 of I minus 1 and plus 2 into dp3 of I minus 1. If they ask about n, just return dp2 of n plus dp3 of n. That's how you solve this problem. I think you can just write the code for this. If not, let's just create vector of int with dp2 5001 comma 0. I'm just creating as 0 dp3 of 5001 comma 0 and dp2 of 1 is 6 and also dp3 of 1 is also 6. For I is equal to 2 till I is less than or equal to n. That's the same thing here. dp2 of I is, let me just copy paste from here to here in the for loop. And if they are asking dp of n, right, so just return dp2 of n plus dp3 of n. Just don't forget about the modulus operation. They have also mentioned that. If you don't know how to code this, go to the link in the description, go and check it. I have given the code link in the description, go and check it. And thanks for watching this video. Please do like, share and subscribe to my channel. Thank you.